In part C, we are given the free body force diagram for a cyclist and the bicycle when they are cornering on a bank track. We are told that the normal contact force exerted by the track is N, and the weight of the cyclist and bicycle is mg. We need to consider the vertical and the horizontal motion to show that tan theta is gr over v squared, where theta is the angle between the track and the horizontal. R is the radius of the path and v is the cyclist's speed. In order to consider the vertical and horizontal motion, we need to have all our forces in either vertical and or horizontal directions. The weight mg is already in the vertical direction, so we are fine with that force. But the normal contact force is not in either of those directions. What we should do firstly is resolve the normal force into two components: the horizontal component and the vertical component. The vertical component, being opposite the angle theta, is going to be n sine theta, and the horizontal component, which is adjacent to the angle, will be n cos theta. We can now look at the vertical direction, and in vertical direction there is no acceleration or movement, so there must be equilibrium, which tells us that we can write the forces going up, which will be n sine theta, equal to the forces going down, mg. So that can be our first equation. We can then look at the horizontal direction. The force that we have is n cos theta, and we know that the cyclist is cornering, so it's following a circular path, which means we need to use the equation F equals mv squared over r. This is the equation for circular motion. Given that the force is n cos theta, that's the only force we have in the horizontal direction, we can replace F by n cos theta and write down the right hand side mv squared over r, and this can be our second equation. We can then have a look at what we need to reach. We need tan theta to be equal to gr over v squared. Since we have sine theta and cos theta, thinking about how we can combine them to reach tan, we can see that if we should remember that tan theta is sine theta over cos theta. So using that, if we do equation 1 divided by equation 2, we will get n sine theta equals mg, and then we are dividing by equation 2, so n cos theta, and divide by mv squared over r. We will have the n's cancelling each other, the m's will cancel each other, and sine theta over cos theta will be tan theta. Then we have g divided by v squared over r, which we can write as tan theta is equal to gr over v squared.